I'm doing it. I changed my mind. I don't want to go in there. There's a lot of people in there. They can hear me. They just locked me up and let me go. I don't want to go. I think I'm going to leave. They won't let me leave. They locked me up and brought me, no, I've got a stool. This is beautiful. If it were not for some inquiring minds, I just love that. Have you all heard that? 1859 from this desk. It's beautiful. And I have a love affair with this desk. It's so precious. If only this desk could speak what's happened on it all these years, a couple hundred years, whatever it is. Well, what I'm proposing to you is today, what is today's date? I don't remember what it is. September 1st, yeah. We are going to make this desk speak around the world. And that's why I came. Now, I want to do something first to demonstrate what it is we're going to do. Are you ready to see some really great science demonstrations, by the way? Really? Yeah, that's too bad, because instead, I'm going to do this. In order for what's going to happen to this evening, you're going to have to pretend like you're 10 years old. Some of you, that was not long ago. Some of you are going, what is it? And so, really, I'm going to be talking to 10-year-old people tonight. And for the amount of alcohol that was consumed down the hall, that's going to be about appropriate, I'm guessing. 10 years old, and you're watching this. And the old man's got something in his hand. I don't know what it is. The old science guy. And he puts it on the candle and, oh, you like that, didn't you? Now, during this evening, if you like something that I do, I would like you, what was that? Let's hear that O again. And if it's really good, I want to hear an ah. If it doesn't work, go meh. But if it really gets down in your belly and loins and heart, go, I want to hear an ugh. A caveman ugh, okay? So much for that mess. So we're going to do an activity to demonstrate what it is we are planning to do to get young people around the world to think like a scientist again. I'll get into it. We just want to get them to think like a scientist. And I want to have some fun while I do it. So I'm just going to do this first activity just for fun. And I don't know if you recognize what I've got. There's a long plastic tube draped around here. Did everybody see it? And it ends up where? Oh, right here. How convenient. Right here it is. I've got a plastic tube that's about 100 feet long. And what else do I have? Ooh, flammable gas. That was my name when I was a professional dancer. Flammable gas. I'm going to fill this tube with flammable gas. And it's going to go all the way around here, all the way over there. We're going to dim the lights. All right, you're with me so far? And then we're going to see what happens. So I'm going to put some flammable gas in here. Here we go. Now, right now, it takes about 30 seconds. I'm filling that tube with flammable gas. And some air is being pulled in because it's mixing right here at the torch head. So there's air and flammable gas going through this tube. Right? And in a minute, I'm going to add the third member of the fire triangle. Do you remember the fire triangle from when you're 10-year-old? What is it? What is the fire triangle? Yeah, fuel, oxygen, and heat, right? I've got fuel and oxygen in there, right? Lots of it. I got fuel and oxygen, so I have to add some heat. What's going to happen? You're 10 years old now when I pull this trigger. We have insurance, right? Okay. Shall we try it? Here we go. Have you got it pictured in your mind what's going to happen? Has anybody seen this before? Well, this is great. This is great. I'm going to get a good grade on this thing. Here we go. And let's see what happens. It could blow up, couldn't it? The whole thing. Because everything's in. I don't know. Let's see. Here we go. In 3, 2, 1. Oh, baby. Oh, what's going to happen when it hits the end? Okay. Well, okay. Okay. The lady was standing on it. I'm telling you. We'll do it one more time. Oh, God, that scared me to death. Isn't that neat? Now, you might have thought, well, it could have blown, the whole thing could have gone, right? Why did it chase through there? Grab your beards and go, now why did that not go? Because everything was in the tube of the fire triangle, right? There was some heat. No, there wasn't any heat in there. That's it. There was fuel in there, but we didn't have heat. The heat just hadn't gotten there yet, had it. Right. Shall we do it again? Here we go. 3, 2, 1. There she goes. This is a great way to torment a cat. Here, what's going to happen when it gets to the end? Here we go, all the way to the end, all the way to the end. They're going to make it all the way to the end. Here it comes, here it comes, here it comes. Oh, hey, there we go. It doesn't take much to make me happy. That's pretty cool, wasn't it? And what would a normal 10-year-old say? Do it again, more gas, whatever. Well, I want to pull up a stool because I am really getting old. Oh, I like this place and I love this desk. I'm supposed to talk for 1 hour only, and I'm a Methodist. I don't think it's going to happen. Now, solving the riddle of the tube for a 10-year-old, what's it going to do? That is pure science. That's absolutely pure science. Right? See, it could blow up, and that'd be great. We get to lose some fingers. But if we're going to be science educators, we just can't always rely on fireworks because, fireworks, kids love the fireworks and everything. So, just for a moment, we were analyzing, like a pure scientist there, what's going to happen. And in order to do that, you have to be a critical thinker. And I put to you that our planet is running low on critical thinkers. I just hate to be cruel. My first physics lesson was taught in 1964. I'm getting old, I can't remember. That's a long time ago. I've been around the world to every continent except South America, and been in thousands of schools, and I have seen kids over these 5 decades, and some kids are doing great, and there's a whole bunch of kids that they're not doing so good. And that group is getting bigger. And I've got frustrated what to do. What can we do? What can we do? Where do we throw our time and our dollars? The problems I see them facing is that the agenda for science education is getting so thick with other things to do. It's piled on to science teachers. They have to do so many other things. Social concerns, dental health, it goes on. And some foolish teachers actually have to want to do things safely in the classroom. I don't know where that one came from, but anything. I do think that our children are suffering from hurry sickness. Just dreaded hurry sickness. I've got to have it done fast. Everything's fast. And science is not fast most of the time. It's test scores around the planet, except for those who are taught to the test. They teach to the test now. But beyond that, test scores have just plummeted, on average. Money's gone, is drying up around the planet. And I know in my country, we lose 20% of the school teachers every year, science teachers. 20% we lose every year. Yuck. And the average teacher in America has 3.5 years experience teaching science. And that's about the time you're getting going if you're a good teacher. And so that's a big problem. And the one that I think is a real stinker, by the way, stinker is a Kansas term where I'm from. We use a lot of terms. You guys speak English a lot gooder than I do, but I think stinker is universal. The kids in Kansas, anyway, are average, 3.5 to 4.5 hours a day with the screen, our new friend, the screen. And with tweens, what did Nick tell me? It was 5.5 hours. And with teens, 7 hours a day. Where everything is pre-digested and spit, and just like a mama bird with bugs. I'll chew it up first for you, son, then spit it out to you through the screen. Now, I acknowledge that there's a lot of good stuff going on in schools, and I've been judges at the international science fairs, and the things are going on. Those kids are brilliant and doing good, but most aren't. And the big hole that I see in the bottom of the bucket, the problem bucket, is kids have a lack of interest. And they have a short attention span. Their imaginations are dull. And I think the worst thing we've done to them with those screens is that we've removed them from the natural world. They don't get to play in the dirt much anymore. They don't get to do things. They don't get to use a screwdriver. Believe it or not, a few months ago, I had a group of 15-year-old boys that had never operated a roll of Scotch tape in their life. And I also think that there's been a shift from hands-on to digital, which it's good in most part, but I think it's gone too far. And I've seen that with the studies. The scores have just died. It just dropped, especially after COVID. So what do we do? And I can't just use fireworks. This thing, if I did this all day, kids would be in class all day. But I can't blow things up all the day. So what a group of us have opted to do who know of Faraday and look at this desk and go, oh, man. I just want to lay on this desk and kind of rub it, see if I can get some of the mojo. Just think. Can I get the power of this desk packaged and shared? And I want to do it around the world. Whatever this desk has got, if we can package it, I want to get it around the world. And that's what I want to do. So I want to give you an example of what we're starting to put together. And then I'm going to tell you what it is. And I hope I can get a thumbs up from you folks tonight. So our first little demonstration, everybody say hello, Luca. Hello. Nothing to be afraid of. I know they're British, but it's okay. If they bite you, they have shots now for it, so it's all right. Now, what is very inexpensive to do that a kid could just get this stuff at the grocery store and do something just jaw-dropping? I want something jaw-dropping in science that I could do for $2. What would it be? So right over there, we've got a little laser pointer that we bought at the grocery store. It's for playing with the cat, right? And we've got it strapped down so it doesn't move, turned on. And then we've got a little plastic syringe that we put some pond water in. Okay? Just went down the pond, suck some up. Or I could use a tube or anything, or use a chopstick and just hang a drop. This is what Leeuwenhoek did in the whatever year it was. And then I've got a screen over there. And so we're shooting that laser beam, that cheap laser, through a drop of water I got at the pond, right? And I don't know if you can see that screen over there or watch up there. Let's see what we see. Ready? Okay, Jacob, you want to help him move that over a little bit? It's not the best thing in the world. Ooh, ooh. Come on, boys, where are you? They were there a minute ago. There goes one. Oh, there's another one. Oh, my gosh. Oh, look, there's a bunch of them. They're eating each other. Oh, my gosh. Nick, do you have a video of what we did earlier? We captured on film. Do you have that? Where is Nick? Can you throw that up on the screen? Oh, yeah. Here it is. Can you see that? All sorts of protozoans swimming around. And I did that on the kitchen table, with $1 worth of stuff. Would you please drop your jaws and go, oh. Isn't that amazing? Okay. I don't know. You want to do another one? Okay. This is best. Hey, listen, you want to leave now? Take a break. This is as exciting as it's going to get tonight. But I think you can see where I'm headed. Let's do another one. Do we have something ready to go? Oh, here. Let's do it with this thing. Have you ever heard of jet lag? I've gone beyond that. This morning at the restaurant, I was at the Mayfair Hotel. I was going, boy, this toast is pretty lousy here in Britain. He said, Jake, your tongue is bleeding. I thought, oh, okay. That jet lag gets you. Hey, Andy, how you doing? Sheriff let you out. Yeah, oh, nothing, never mind. Andy used to work here. All right, here we go. So I've got this vacuum, a shop vac, right? No big deal. But you remember, you're 10 years old now. And I put this pipe on the exhaust end, and I put some soda straws in there, in the tube, so that instead of coming straight out current like that, there's straighteners inside here, little soda straws, just to straighten out the airstream. And I've got a balloon with some water in it just for ballast. And okay, that's cool. I'm done. Oh, yeah. But here we go. Give me a noise. Oh, that's sad, isn't it? These people get excited about that. So let's put some science into it. Well, that was science, because the air pressure underneath the balloon was tipping, blowing up, and everything's cool. Higher pressure on the bottom. And it's like, okay, got it. What's going to happen, and this is for a dish of ice cream, when I tip this thing sideways? Now, you're 10 years old now. What's going to happen when I tip this thing sideways? And we're all going to die. Sorry, people on the front row. I don't want you to worry. I've done this experiment 4 times. Yeah. So really, what's going to happen? Yeah, stay, fall. It could shoot off. It could fall. And see, this process, kids' attention span now is 15 seconds. But the playing with something like this, they'll be focused on it for a lot longer than 15 seconds. Let's try it again. Now I'm going to tip it. See what it does. Oh. Let's have a noise. Woo! Now that doesn't look right, does it? To a 10-year-old, say, why didn't that fall down or go away? And then you've got them hooked. Well, why didn't it fall down or shoot away? And what was touching it? Well, the only thing that's touching is air. And how does air know all this stuff? I don't know. But just that process of doing an activity that will capture them for longer than 15 seconds is what we're shooting for. That kind of thing. And of course, you could get into the aeronautics of this and the dynamics and start measuring things. I say, nah, not when you're 10. Put that off till later. And if you're really good at it, by the way, I'm not going to take the time to do it, you can get it to start to bounce like this with the exhaust. And then you tip it sideways, it goes out and comes back. And you're going, how in the world is it doing that? And Grandpa won't tell you. I want you to figure it out. I just want you to think, sit there and go, well, it's going out there and it's coming back. It's going out there and it's coming back. How does that balloon know to do that? What is going on? I don't know. Oh my God. Just shot an innocent bystander. My golly. It's hard being me. So why you're going to be amazed at who's doing this stuff that's around here. AY, are you here? You're here? Oh, are you awake? Okay, just checking. This is so cool. Why am I doing this way? Why would I want to do silly little activities like this? Why not do some fancy, well-designed, pedagogically correct, socially correct scenario? This was not my idea, necessarily. I've got a group of friends. Can you throw that picture up there? I think. Group of friends. Now, everybody in that picture has a Nobel Prize except me. Dang. Almost had it. I can't even spell Nobel Prize, much less be. But these are people that I worked with, and they're our little advisory council when we first started. A couple of them have passed away since. But Sheldon Glashow, the guy standing next to me, I said, Sheldon, what did you do when you were 10, 11? What got you interested in science? Got a Nobel Prize for discovering some subatomic particle. What got you going? You know, what was it? He said, I used to sneak in the closet and steal my dad's shotgun shells, take the powder out, and make bolt bombs with nuts and bolts, and then throw them out the window. And they go, bam, on the sidewalk. I said, you did? He said, yeah, and I learned some things about how hard my daddy can hurt. Yeah, he was bad. And Linus Pauling and Leon Lederman, Leon's the guy down in the front row, smiling there. He's a dear friend, and they both discovered that if you took a book of matches, folded it shut, and put it on an anvil or something, and smacked it with a hammer just right, it explodes, which it does. And he announced that at a meeting, American Chemical Society, and I think half the chemists, when they got home, they're going, is there any matches in the house? I did, and the missus was, what happened to the front of your shirt? It's all these holes in it. And I'll move down to Rosalind Yallow, the little lady in the corner there, Nobel Prize in Medicine. She was a dear, dear friend. And Rosalind, what did you do that got you connected? Your first science activity? She said, well, I was at Bryn Mawr School, and we were all hot for Bing Crosby and Frank Sinatra, but they wouldn't let us have the radios on. So we built a crystal radio, and I didn't know how to make an antenna, so I took a picture down of the school matron and put wire around it. And that was our antenna, and I would twist that thing. And later, that lady used that same thing to work on radio immunoassay, for which she got the Nobel Prize. That same thing, right? She said that was my first big science thing. She said it just got my head going, trying to pick up Frank Sinatra on the waves there. Like that. Sweet thing. And I've got a picture of my first, well, not exactly a picture, but this is what I did. Somebody said that alcohol boiled at a lower temperature than water. And I thought, well, that doesn't make sense. So I thought, surely, and I put it on the stove, and by golly, it did. So let's do that one. Oh, right here. Thank you. My dad was a captain in the fire department, and I learned you do not pour burning alcohol down the sink. It will melt the garbage disposal rubber and set the nylon curtains on fire. And they make a neat noise when they burn, though. They go, zoo, zoo. Somebody else made that noise, you know. Who made that noise? Somebody did. You know. So this is a standard old thing. The last time I was here, we were shooting smoke rings out of a box. And you can get any size container and fill it up with any smoke. And you say, well, Jake, where are kids today going to get smoke? And I go, too much smoke going on around. But even cigar, you get some smoke. They'll figure out where to get smoke. And I'll put some smoke in here. Just have to hit the button. Is it going? Ooh, look at that. I'll fill it with smoke. So what's in the box? There's air and there's smoke, right? And I'm going to pump it out in a second. But it's going to come out a square hole. Oh. What's it going to look like? Picture it in your brains. You're 10 years old. So you got it full? And don't worry about this smoke. I looked at the label. It says it's not carcinogenic, but it does have a slight laxative effect. So if I have to speed up, see what happens. See what happens here. Do we get it? But what? Now, it's round, out of square hole. Now, you can make this any way you want, with an oatmeal box or anything. You shoot smoke rings just like that with a rubber band and trash bag. But you're going to have to make one of these at home, which you could out of anything. They don't have to be smoke rings this big. But if you'll look very carefully at the hole when they first come out, can you see for a fraction of a second they're square? And then it gets rolled into round? Well, who's doing that rolling? If you do it just right, you'll get a square ring. Square. You see it slightly square when it comes out right there? That thing like that. It's square, and then it's getting round. And somebody's rolling it like rolling clay or something like that, right? And just to sit there and take a careful look at this when it's coming out, you say, there, hold it, right there, it's square, right there, it's square. Who would care? But half of the discoveries now with exoplanets are when they're looking for little bitty changes around stars, a little flicker. And scientists have to learn to look for those little bitty changes. And you have to train your head to do that. And how are you going to do it? I don't know. That's kind of cool. So where am I getting the ideas for this? These ideas that we were proposing starting tonight, September 1st, 2023. We're going to start something at the Royal Institution of Great Britain on this desk. Ooh, baby. Where are we getting the ideas? Well, show us our studio. This is where I work. That's Faraday Studio. And it's not as old as this place, about 150 years old. But we've worked over, I don't know, the last at least 100 years, not me, but my predecessors, and have collected, I think it's the world's largest collection of science activities, somewhere between 20 and 30,000 of things like this. If you would say something to me, say, Jake, I need a science activity about purple carpeting and mustard, I think we would have something in the files. So that's where we're extracting this stuff. Our crew has been working on network television series. I wrote a show called Mythbusters and MacGyver years ago. And all around Discovery Channel and National Geographic, we have so many activities like this that we're trying to get out along with the Royal Institution. And we've done thousands of live shows. I know when Mr. Wizard was on the air, we did 5,500 live shows a year, and we've kept all those activities and we're extracting from them. Here's another activity, and boy, this better work. We had a terrible time. This was good old reliable science activity. We get to London, of all places, and it wouldn't work this morning, would it? You people sweat too much because it was too... Now, what's supposed to happen, do you have a little sample of what's supposed to happen? This is what's supposed to happen. Move this out of the way for you people back here. So you tell a kid that all you need is a piece of plastic in the house, a bottle, something plastic, and the cat. I had trouble getting the pat on the airplane, and you find your own thing. It doesn't matter what it is. I'm just going to take that little stick and balance it on there. This is a magic stick. It will point towards the smartest person in the room. And what am I doing right now? I'm putting a static charge on this thing, and you guys all know this stuff. But if I can put a static charge on there, I can get it. You people are sweating like... Are you seeing this? Everywhere else on the planet Earth, this is... And then I get in here. Dang. That's some science in itself, isn't it? Oh, my gosh. I don't believe this. And everybody's looking at me, and it's not working. This is why people drink. Oh, can you believe this? Huh? Give me can you? Oh, we'll try a balloon. No, that won't work. Hand me that balloon again, would you? Thank you. That's my helper, Jacob Brown. Everybody say hello, Jacob. Yeah. He's worked with me several years, and we've got him therapy. And it's going to be okay. That's the dangest thing I've ever seen. I planned it this way. What's supposed to happen, and you believe me, right? This is supposed to spin, and then you'll go, oh, that's cool. Let's try it with something bigger, and we're going to get that thing to spin around. Put some oil on there. Okay, this is embarrassing as heck. I'm going to lose almost 2 minutes of sleep over this tonight. Are you guys too disappointed? Yeah, maybe. The idea is that you put a static charge on anything. You can walk around the house, and what can you do with it? You wait till your old man's asleep, and you go up and... Or you torment a cat. Or you make a party game. Who am I going to kiss next? I swear to you, I don't. But if you all cover your armpits, there's just too much. I'm sorry that one didn't. We're just saying, okay, never mind. We move on. That whole thing moves with a little charge, and everybody goes, ooh. Didn't work. So this thing we're going to propose to you this evening, talk about, that's embarrassing, man. Jeez. Well, only half of them are asleep anyway. They didn't miss anything. So, do we have any authority to do what we're proposing? And the authority is, we have a wizard heritage. That character on the left is Wizard 1. We love him. I wish I could shake his hand, for everything he did. Just spend 15 minutes talking. Wouldn't that be brilliant? And the fellow next to him, Hubert Allier, was a professor at Princeton. My chemistry professor, I don't know, more than a half century, he taught me chemistry a long time ago. Walt Disney made a movie about him called The Absent-Minded Professor in the 60s. And flubber in that movie was a takeoff of their discovery of Teflon, fluorinating hydrocarbons. And he was taught chemistry by Madame Curie. And right after World War II, when the bombs were dropped, atom bombs, they sent him around the world, the UN did. People were panicking about this new nuclear energy. And he went to 88 countries and calmed people down with his lectures on atomic energy, weapon for peace, and told all the great things that atomic energy can do. And he was Wizard 2. And I don't know how many shows he did. It was in the tens of thousands in his career. And he passed the wizard torch to Don Herbert. And that guy was on television for 52 years in the United States. I watched him in 1951 every Saturday morning at 10 o'clock religiously. And we learned these activities that doing. And then that guy there, God, what an animal he is. Good looking guy. I got the job at, you got another picture? What have we got a picture of? I'm tired of looking at me. Yeah, we met at this place. It looks familiar to you. We had a little wizard convention, and there's Peter Day up there, and he was director of the Royal Institution. And so we started the wizard thing about a third of a century ago. So if anything goes wrong, you blame Peter Day, right? He was a character. And what we want to suggest to you that what we're going to do, will it actually work? Because everybody's got an idea on how to fix science education. Everybody's got an idea on how to plug up the holes. And what we're going to propose, will it work? It's got to be easy to do and inexpensive. It's got to be something that teachers or non-teachers can do. It's got to be involved with sharpening science skills, not just memorizing stuff, but sharpening thinking skills and making you crafty and sly and persistent and joyful at the same time. You got to love it. And it's got to be delightful. So we've been testing them, haven't we, Nick? Where have we tested this stuff? And I go down the list. Scotland, the U.S., on Discovery Channel, National Geographic, the Science Channel. We've been to South Korea, Japan, Saudi Arabia several times, Nigeria, and even, where was that one place we went? Oh, no. There, yeah, right there. There, yeah, okay, we tested them here. And those people, that audience was smiling. I don't know, but it was right. Anyway, we've tested this stuff for about 8 years. And we've had tremendous success. Every place we've gone, we went to Saudi Arabia with a team from the Royal Institution, and we did these silly little activities in a booth at a science festival. It had 119,000 Saudis came to it, and they voted what was their favorite booth in this huge, and it was this stuff. This stuff. That's why we're proposing it. Wow. Let's do another activity, shall we? Oh, this one. Y'all got your stuff. See why I'm starting to talk like it. Y'all got your stuff. Let's take this one out. Let's grab one of those balloons. This is such an exciting evening here. They're so excited. Now here's a balloon, and we want children to understand that science is connected to daily life, just like the motto of this place, the science of common purposes. Now what am I? I'm 10 years old. I'm sitting at home. What can I do with anything in the house that is of any grand significance? Like, I buy a little science kit and I make a couple of little drops and you go, woo, or make a little volcano, woo. But what real gut-wrench, real solid bit of science could I do for a few pennies? Because we don't have much money, and the last time I got in trouble for setting the carpet on fire, so I can't do that. So what else could I do? This is really neat. This activity changed the planet, changed commerce, it changed borders. So I want you to take this little balloon, and I don't have thermometers for everybody, so we're going to use the thermometer that's built into your skin, all those nerve endings that are ending right here. I'd like to have you put it up against your forehead and just notice the temperature of it. Okay. Now what I want you to do is to grab the balloon, and in a minute you're going to stretch it as far and as fast as you can and put it back up there and tell me what you feel. You're going to do it like this when I say go, but don't do it yet. Right? You're going to go and put it up there. So you ready to do it? I said 1, 2, 3, pull and stretch. Tell me what do you feel? Did you feel some heat? So let's put it back out here and get back to room temperature. The question you would ask a person at this 10-year-old, where did that heat come from? Well, a modern youth would say, I don't care. I want a pizza. This is dumb. But then I'm going to do a little farther here. We're going to think like a scientist for a second. What would be the opposite of heat leaving that balloon? You're 10 years old. What's the opposite of heat leaving that balloon? Cold leaving? Cold? You say you're 10 years old. The opposite of heat leaving that balloon would be heat going back into the balloon. Well, what would be the opposite of stretching? Contracting. So let's grab our beers and go, now hold on now. So if I stretch this and feel the heat when I stretch it, what am I going to feel when I let it go back together? And see this little thing we're doing in our head, analyzing, right? You're actually taking the time to analyze. So let's stretch it, feel that heat, and hold it out there. Yeah, I feel the heat coming out of there. Yeah. I kind of blow it away. Now, I'm going to let it go back together. Did you feel that? Were you expecting that? So what kind of noise do I get? Okay, then. I don't want to say what's going on here. Isn't that cool? Let's try it. Ready? Hot, cold, hot, cold, hot. Catherine, you owe me $20. I bet her I couldn't make you all look stupid at the same time. Isn't that something? Now, what great thing in the world would this have anything to do with? Who said that? Right there. Give that man a hand. Okay. Refrigeration. This demonstrates the concept of refrigeration, that you can actually move heat around. And of course, a refrigerator takes a gas and squeezes it on the outside of the building or the refrigerator and blows some air on, and then it goes back inside the refrigerator and it expands back in there. And it goes back out and squeezed, and it's pulling the heat out of the refrigerator or out of your house. And the kid goes, that's the magic of a refrigerator? I said, yeah, there's little guys in there going like this. You can hear them. They're going, blah, 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 blah. Isn't that a neat little bit of science, though, really? So what's the plan? My plan is this. We started Midnight Science Club a few years ago as a test site with the help of Ace Hardware. Hey, Nick, how many viewers did you say we had total so far?
Hundreds of millions.
Seeing these activities, people flock to them. We established a foundation, Faraday Foundation, named after our buddy and his desk. We have identified 200 activities, just like you just experienced. 200 of these. All right? We've identified those. And we're honoring Faraday and his motor. When I was talking to Catherine and somebody here at the ROI, they go, hey, it's 200 years of Faraday. And I said, 200 Faraday, 200, 200, Faraday, 200? We're calling it the Faraday 200. 200 activities. We've developed partners worldwide. We've got some partners lined up, some pretty cool. That RI, I don't know. We might have them in there. They're pretty good folks. I sure like the staff. Hey, by the way, you don't pay your staff enough. Did I say that right? There you go. Okay, I want to make sure. And the neat one is, I'm going to start crying. We became an impact partner with the United Nations Sustainability Development Goal Program. We're going to be one of the goals, the 17 goals for the world's. I can't even talk. I'm getting all emotional here. This silly little exercise, this Faraday 200, of doing these things has been picked up by the United Nations to take to every kid on the planet between the ages of 10 and 14, the critical thinking points. We catch them when they're 10 years old until they're 14. Because, after 14, if you don't catch them, they're gone. They're gone. So we're going to do that. And you guys are going to get a buzz out of this. This is going to get an UG. Sitting in the audience is His Eminence, the ambassador from the United Nations, A.Y. Young. A.Y., would you stand up? Or this is A.Y. Young, ladies and gentlemen. Thank you. Okay, thank you, A.Y. He's going to sing tomorrow. But A.Y. is the, can we say what your title is, or secret? The new world youth leader for the United Nations. Say, what is it? What is it?
Sustainable Development Goal Champion of the world.
So, AY, are we going to take these things around the world?
We're going to get the world plugged into science.
Right from this desk, starting tonight. Tonight, right here with you ugly mugs and me. And we're going to see that once a week for 4 years, every 10 and 14-year-old we can get our hands on or attention of is going to get one of these activities every week for 4 years. And I'm betting the farm. I'm going to spend the rest of my career and my life getting kids just to do these activities. I'm not going to worry about much else. Then they don't have to do good science. They don't have to do good math. Just get their hands dirty, playing in the mud again, doing things with sticks and tree branches and all the things that are in this list. And each activity that we're going to do has a set of scientists in charge of it. They're not teaching science, they're teaching that activity. And we have people like John O'Meara, who's the chief scientist at the Keck Observatory. We have Mike Massimino, the astronaut that worked on the Hubble telescope. We have people lining up to be keepers of, and it's easy because we're just asking them to take care of an activity, to be the guru of doing this. I have a Nobel Prize in physics, and I'm going to show you how to do this. Dudley Hirschbach wants to teach kids how to make a planetarium out of a flashlight. It's so cool. We're going to start that at the Royal Institution on Michael Faraday's desk. Isn't that cool? So what I would like to do, and we might have some time to do some more stuff, because if that bell goes off and I'm still talking, I'm in trouble, right? Did I leave anything out?
I think we have one more demo.
Well, now we got one. They got the big one. So I want to show you this. This is my primo excellente. Now, what would be an activity that would really get a kid's head going, wow, beyond ugh? I think that's what we're going to call this, beyond ugh. We're going to do it, aren't we, AY? Yes, sir. This is it. So if Michael were here, as a matter of fact, Michael is going to be here, isn't he? Charlotte, are you here? Yeah. This is the historian of the Royal Institution, Charlotte. Everybody say hello, Charlotte. Charlotte. She's bringing, where are you, girl? Oh, there she is. Now, I can't touch it. No. Michael, I know you're in there. You see, this is Faraday's candlestick, and it still has his wax on it. I was going to clean it and put a new candle there. Charlotte, you know, that's why I'm limping. But I think there's a little hair in that wax right there. You can see it. If I'm lying, I'm dying. Right there it is. So that's Michael Faraday's hair stuck in the wax. So that's all we got left of you, Michael. So if you were here, buddy, this would be the activity I would like to show you that I think would touch your heart and make you think and be jaw-dropping. A jaw-dropping. If you can get the young person to sit still long enough to do this, and then all of a sudden a bell will go off in their head and they're going to go, oh my, oh my. So are you ready to do this? Now, I bought, this is, ooh, I almost touched it. Oh my God. You want to grab that? Where's that girl? Where is Charlotte? Charlotte, I might have an accident. Thank you, Charlotte. So this is a weather balloon. No, I bought that at the store for $1.50. And how do we get this? Inside's a golf ball. And by the way, that little package of balloons that you got, there's some other stuff in there. I'm not going to tell you what to do with the balloon and the balloon. I'm going to have you take it home and figure it out. So how do we do this? You grab it here. Show me how you did it earlier. Yeah. Get it down there. You got the balloon down there. Yeah, and you grabbed it. Yeah, you grabbed it. You grabbed that balloon. Yeah. So he's going to do it because I was afraid I'd break it. Here, go do it. These balls are golf balls I bought at the store, and they glow at night. So I'll shop you because I didn't want to break the balloon and make an ass out of myself twice in the same evening. Isn't that sweet? Those are 97 cents at the dollar store where we got them, right? That's kind of cool. And they burn for 2,500 hours, but they go off every 8 minutes, and you got to send them back. There's for night golf or something, right? Now we're going to dim the lights, and I want to see if I can get a grunt out of you or something. We're going to make the world's neatest gyroscope right here. Ooh, can we turn off the lights? Let's see. Are we ready? Can we turn the screen off too? Make it really dark in here? I don't know if we can or not. Probably not. Oh, I just hurt myself. Oh, there, that's better, isn't it? Now, can you imagine making one of those with your kid? You say, oh, that's cool. And from a distance, this just looks like heck when you're seeing it down. What in the world is that, a UFO? Listen to that thing. And if you do it well, I'm too clumsy to do it, but you can rotate this balloon, and the rotation will still stay in the same plane, like the gyroscope on the jet plane. You know? There it is. I finally got it. Isn't that sweet? Okay, that's cool. But what kind of scientific thinking would I have a 10-year-old do with this? And the question I would pose, Michael, are you there, Michael? He's here. That ball requires energy to keep going around. Okay. 10-year-old kid said, yeah, I do. Where's it getting the energy to do that? Now remember, you're 10 years old. Where's the energy coming from? Anybody? Anybody? You? Me? Yeah. Coming out of my hands, isn't it? Well, how did it get in my hands? Am I moving? Well, but how am I moving? Where's that coming from? I'm being nasty, aren't I? Where's it coming from? Yeah. Come on. Oh, yeah, every group's got a smart aleck. We got them. But it's coming from my arms, and it came from inside me for something I ate. There you go. This goes all the way back to the sun if I take the time to figure it out. Isn't that amazing? Well, it's even more amazing for me, for a 10-year-old, said, oh, by the way, that energy that's coming out now, you carried it around with you today, and you brought it in here, and you're letting it out right now. And kids will go, I'm carrying energy inside. How did it get in there? And where's it going now? I hope you like that, Michael. That's the best I got. But when I saw this, I was just enamored with, a $1.50. Do you think kids will be playing with this in the front yard? And discussing it? Yeah. So we're going to put together 200 activities called the Faraday 200. Hearst Television wants to make a television show. They're going to be on the internet. We're going to have scientists running it, lesson plans for teachers, plans for parents, grandparents, just so you can do these activities at home, so we can plug up that hole in the bottom of science learning. Thanks to this desk, and that's the way we're going to take the desk around the planet. Now, did I beat the hour? Because I've got extra activities. I've got extra activities. Yep. I don't know if that's what you were expecting tonight, but we took advantage of the hospitality of this place to announce this activity, and we want the Royal Institution to be a recipient of whatever happens from this enterprise. Shall we do one? We got time for an extra? This is sweet. And I'll be glad to take any questions, or is that where? Oh, I ran her off. Well, that's all right. Shall we do one more? Yeah. Okay. You guys got to get to the pub or whatever afterwards. I didn't want to slow you down. I really love this building, and I love the people in it. I'm just so impressed, and we're so glad to be working with the United Nations to take this idea around the planet. Do you know right now in Syria there are 250,000 ISIS orphans, ages 9, 10, 11, and 12, that were born behind the chain link fence, and they're still there. And they have no access to any science. They're going to get these. They're going to learn science there with these activities. This is one I love to torment my grandkids with. Some of them still have nightmares over this one. You know what a gremlin is? A gremlin. A little World War II. Well, the Disney movie about the gremlins, but there was little creatures that lived in the airplanes and sabotaged them. The gremlins did it. The gremlins did it. There he is. Yeah. So, are the larvae already in here? Is it already loaded up? It's loaded up. They're in there. Are you in there, you little rascals? Ooh, don't scare me. This is a full-grown one, but the larvae of the gremlins are just horrendous little creatures, and I've got them in a can. Oh, be careful. What does it say? Oh, thank you for putting that on there. Now, hold on, boys. Let go. Let go of the lid. Let go of the lid. Oh, yeah. Okay, don't even try it. Okay, right there. It's feeding time for the gremlins, and I'm not going to stick my finger down in there at all. Matter of fact, I think I'm going to lower this so they don't jump out. Because when they... where are we feeding them? I forgot. What did you guys bring? What is it? Oh, styrofoam. They love styrofoam. Nobody's fed their gremlins before? Remember, you're 10 years old, right? And I've got them in here. Have you ever seen? Okay. So, you guys want to help me do this? We'll just feed them the styrofoam peanuts. Oh, listen to them down there. Listen to them go. Listen to them. Eat, boys. Girl. Oh, watch it. Watch it. Watch it. Watch it. Let's get a bunch of this in here. Oh, yeah. Oh, there they go. There they go. Oh, there. Oh, I see. I'm supposed to be up there. Oh, watch out. That one's getting out. Okay, there we go. Get him down here. Okay. Okay, you got it? We got a log jam in our pipe. There we go. Yeah, they're getting down in there. They're not full. They'll be eating all night long. Oh, hear them down there? Hey, you guys in there? Oh, yeah, there they go. They're going. Are you still eating? What's going on? Oh, yeah, they are. Dang. They just can't reach it. Oh, yeah, there it goes. What? Man, you guys are hungry. Has anybody figured out what's going on? What are you thinking? Who's yeah? Well, what's going on? Well, there's nothing, there's no hole in the table. And you know, the kids now are screaming, what is it in that can? How do they eat them so fast? That's amazing, isn't it? Oh, there we go. Well, we could do this all night. Isn't that amazing? Do I get something? Yeah, they're down there so fat now, I don't need that thing. But look at them, they're in there just eating away. Does anybody in the audience have an idea what's going on in that can? Excuse me? Yeah. You won't ever give this secret away. It's fingernail polish remover. And as a matter of fact, we could put an entire bushel basket of styrofoam pellets in that can and make up all sorts of lies and stories to scare the kids with. And what's in the bottom of this is about 1 finger of acetone, fingernail polish. And it doesn't really dissolve the styrofoam. It lets it break it because the styrofoam's still there. And if it wasn't such a... well, I'll just go ahead and put it out here on this tray. The styrofoam's still there. There's the acetone. And there's all that stuff. So there's the styrofoam. And why would I want kids to do that? I want them to be good at telling stories and making up whoppers so they can write grants when they get older. You know? So, we got tons of them. Oh, should we do the thing? You got one? Oh, yeah. This is good. What happens to little boys that play with chemicals? Oh. I used to do this when I taught chemistry. This is just for fun now. We didn't have fun before. Got a styrofoam head. And do you have some styrofoam there? What do you think's going to happen if I... This is just fun to see. Don't do it. Don't do it. Please don't do it. Oh, no. Oh, no. Oh, no. Okay, that's so much for that. I don't know. Would that give your kids nightmares? Help me, help me. Oh. Did I do it with the bell?